Here's more practice for Math 112, test number 3. F of xy is given. To evaluate f of 1, 4, we replace x with 1, and we replace y with 4. 1 squared plus 2 times 1 times 4 plus 4 squared. Replace x with 1, replace y with 4. This equals 1 plus 8 plus 16, which is 9 plus 16, that's 25. To find the partial derivative of z with respect to y, we treat x as a constant. That makes the derivative of 2x cubed 0. The next term is a constant times y. The derivative of a constant times y is the constant. Y is the variable. And the derivative of negative x is 0 because we're treating x as a constant. The partial derivative of z with respect to y is 3x. F is a function of x and y. It can be written as, in parentheses, x squared minus y squared raised to the 1/2 with a 1 understood in front of the parentheses. The partial derivative of f with respect to x means treat y as a constant. So the derivative is 1/2 times 1, which is 1/2. What's in the parentheses gets copied. The exponent 1/2, we have to subtract 1. 1/2 minus 1 is negative 1/2. And then the derivative of what's inside the parentheses is 2x. Because with respect to x means x is the only variable. We're treating y as a constant, so the derivative of negative y squared is 0. So we can say 2x times 1 over this 2 in the denominator, and we put x squared minus y squared to the 1/2 in the denominator. By moving this to the denominator, it makes the exponent positive 1/2 instead of negative 1/2. And the 2's cancel. So in simplest form, we have x over something to the 1/2 can be written as the square root of, in this case, the square root of x squared minus y squared. Riverside Appliances has the following production function for a certain product. T is a function of x and y. Equals 1800 x to the 0.3 times y to the 0.2, where p is the number of units produced with x units of labor and y units of capital. To find the number of units produced with 2,500 units of labor, that means 2,500 is going in place of x. And 1,700 units of capital, that means 1,700 is going in place of y. That's going to be 1,800 times, where the x is, we put 2,500. And that's going to be raised to the 0.3. And next to that we have y, which we replace with 1700, and that will be raised to the 0.2. And we take out our calculator. $1,800 parentheses $2,500 close parentheses raised to the 0.3. Use the arrow button here to get the cursor out of the exponent. Parentheses 1,700 close parentheses raised to the 0.2. And we're going to round this to 83,319 because it said to give the answer to the nearest whole number, 83,319. To find the partial derivative of p with respect to x. So we're going to treat y as a constant. First, I'm going to rewrite the given function. P is a function of x and y. I'm going to rewrite it in this order, 1800, and then I'm going to write the y to the 0.2, followed by the x to the 0.3. Because if I want to treat y as a constant, because with respect to x means y is the constant, the partial derivative of p with respect to x is this exponent times this constant so on my calculator I'm multiplying 0.3 times 1800, so that comes out to be 540. But y to the 0.2 is part of that constant. And then next to that we have x to the whatever 0.3 minus 1 is. 0.3 minus 1 is negative 0.7. That's how we find the derivative. The exponent and the constant circled in red get multiplied. And then x to the 0.3 becomes x to the 0.3 minus 1, which is 0.7. So up here, we're going to find the partial derivative of p with respect to x when x is 2,500. So it's 540 times, oh, and the y is 1,700. So it's 1,700 to the 0.2. And next to that, we have x, which is the 2,500, raised to the negative 0.7. So we'll see that here. 540 parentheses 1,700 close parentheses raised to the 0.2, right arrow, open parentheses, 2,500 close parentheses raised to the negative 0.7. Enter. And this is 9.99. We're going to round to the nearest whole number, which is 10. Here we would get the 83,319, and this one's 10. partial derivative of p with respect to y, that means we're treating x as the constant. So we're going to take the exponent 0.2, and now this time 1800 x to the 0.3, all of that is the constant. 0.2 times 1800 is 360. And the x to the 0.3 is part of that constant in front of the x. And then we have y to the 0.2. We make it y to the whatever 0.2 minus 1 is, which is negative 0.8. And then we're going to calculate the partial derivative of p with respect to y when x is 2500 and y is 1700. So we'll have our 360. X is 2500. That's raised to the 0.3. And then we have y, which is 1700. And that's raised to the negative 0.8. $360, parentheses, 2500, close, raised to the 0.3, right arrow, parentheses, 1700, close, raised to the negative 0.8. Enter. And this also would be rounded to the nearest whole number of 10. A firm produces two kinds of golf balls, one that sells for $3 and one priced at $2. The total revenue in thousands of dollars from the sale of X thousand balls at $3 each and Y thousand at $2 each is given by R as a function of X. Actually, this is a kind of a typo. It should say R as a function of X and Y. Sorry about that. 3x plus 3y. The company determines that the total cost in thousands of dollars of producing X thousand of the $3 ball and Y thousand of the $2 ball is given by this, which that should also say C is a function of X and Y. Well, the word profit just means the revenue, which is here, minus the cost. So it's minus all of this. That's what profit is, revenue minus cost. So I need the 3x minus negative 9x. 3x minus a minus 9x is 12x. We also have 2y minus 6y, which is negative 4y. But it's minus all of this, not just the x term and the y term. So it's going to be minus 2x squared and a minus, so that will be a plus 2xy. And minus a y squared. This we already dealt with, and this also, but we also have minus 7. Try to squeeze that in there. So that all of this is the profit function. We just took the revenue, which is above circled, minus the cost. all of these in the cost function got negated because it's minus all of that. In order to maximize profits, we need the partial derivative of p with respect to x. So we're going to treat y as a constant. With respect to x, we'll treat y as a constant. The derivative of 12x is going to be 12. The derivative of negative 4y will be 0. The derivative of negative 2x squared is negative 4x. The next term is 2xy, which is the same as 2yx. And y is a constant. The derivative of a constant times x is just the constant. And the derivative of negative y squared minus 7 is 0 because all of that's a constant. We also need the partial derivative of the profit function with respect to y, so we're going to treat x as a constant. Treat x as a constant. That means the derivative of 12x will be 0. The derivative of negative 4y is going to be negative 4. The derivative of negative 2x squared is 0. The derivative of 2xy, that's 2x, is a constant, so it's a constant times y. The derivative is the constant. And the derivative of negative y squared is negative 2y. And the derivative of negative 7 is 0. We need to find when both of these partial derivatives are equal to 0. And an easy way to solve this is to add these columns. 12 and negative 4 is 8. Negative 4x and 2x is negative 2x. 2y, negative 2y is 0. So we're at nothing there, but 0 plus 0 is 0. And then if I subtract 8 from both sides, and then divide both sides by negative 2, we get x equals 4. X is 4, so that means 4,000 balls at $3. To get y, we replace x with 4 in either one of these equations. I'll take the bottom one. You could use the other one if you want. Negative 4 plus 2x, we now know that x is 4, minus 2y equals 0. That's negative 4 plus 8 minus 2y equals 0. Negative 4 plus 8 is 4. So we have 4 minus 2y equals 0. Subtract 4 from both sides. Divide both sides by negative 2. Negative 4 divided by negative 2 is positive 2. So y equals 2. That means 2,000 at $2 each. The cost for a manufacturer of producing X units per week is given by this function. To the nearest cent, what is the marginal cost? Marginal cost means the derivative of the cost, which is going to be the exponent 3 times the coefficient, 0.005. So that's 0.015, and then this becomes x to the second power. And the next term is 2 times 0.6, which is 1.2. X to the second becomes x to the first. And the derivative of 10x is 10, and the derivative of 100 is 0. So to find the marginal cost when 500 units are produced, we find C prime when x is 500. X is the number of units. It'll be 0.015 times 100 squared plus 1.2. I mean, this is 500, sorry. Plus 1.2 times 500 plus 10. And you can do that all on your calculator, but I'll do it a little piece at a time, just for fun. 500 squared is 250000, and 1.2 times 500 is 600. Don't forget the plus 10. 250000 times 0.15 is 37,500, and 37,500 plus 610 okay, so there's a mistake. Let's see if we can get the mistake figured out. The derivative is 0.005 times 3. That's right. 0.6 times 2 is 1.2. 500. So the mistake is right here. I left that 0 out. 0.015 times 25,000 is actually 3750. And 3750 plus 610 is 4360. $44,360 is called the marginal cost when 500 units per week are manufactured. To find, so this is the same function. To find C of 500, C of x is given. We're going to replace all these x's with 500. So I'm going to say 0.005 times 500 to the third plus 0.6 times 500 squared plus 10 times 500 plus 100. I'll just put all of that in the calculator. 0.005 parentheses 500 close parentheses raised to the third plus 0.6 parentheses 500 close parentheses raised to the second plus 10 parentheses 500 close parentheses plus 100, and we get 780,100. To find C of 501, it's 0.005 times 501 to the third plus 0.6 times 501 squared plus 10 times 501 plus 100. And that comes out to be, to the nearest cent, 7.84468 and 11 cents. By the way, this one up here was 780,100 and 0 cents. if production is increased from 500 to 501, the cost is increased by something. It's going to be whatever this amount is, 7, 8, 4, 4, 6, 8, and 11 cents, minus what the cost was up here, 7, 8, 0, 1, 0, 0, and 0 cents. And that is $4,368.11, which shows that if the production is increased just a little, from 500 to 501, the cost, the increase in cost is called marginal cost. That's why 4360 and this answer are pretty close, only off by $8. Equilibrium is when supply, which is x squared plus 5, is equal to demand. To solve this equation, it's called a quadratic equation, so we have to get one side of the equal sign to be 0, making this a minus 50 and making this a plus 4x, so that we have equals 0. But then 5 minus 50 is negative 45. So we have x squared, then there's a plus 4x, and then these are like terms. 5 minus 50 is negative 45. And then we solve this by factoring or by using the quadratic formula. If you know how to factor, then this is x times x, and this is 9 times 5, positive 9, negative 5. And this equation is true when x plus 9 equals 0, or when x minus 5 equals 0. So this equation is true when x is negative 9, or when x is positive 5. The negative number doesn't make sense. Nobody produces a negative number of anything. So the equilibrium point is when x is 5. To get the other coordinate, we plug 5 into either one of these. For example, 5 squared is 25, and 25 plus 5 is 30. Or you could have plugged 5 in here. 4 times 5 is 20, and 50 minus 20 is also 30. To get the producer surplus, the formula for producer surplus is we multiply the coordinates that we just found and then subtract the integral from 0 to the x coordinate, the integral of what producers do. Producers supply things, so we need the supply function here. In this problem, the x coordinate is 5 and the y coordinate is 30. And then we have minus the integral from 0 to the x coordinate of x squared plus 5 dx. So ignore the minus and everything before it for a second. The integral of x squared dx is x to the third over 3, and the integral of 5 dx is just 5x. And we put a bracket here, 0 and 5. So everywhere there's an x, we're going to put 5. So 5 to the third over 3 plus 5 times 5. And technically, this is going to be minus 0 because when both of these terms get x replaced with 0, we'll have 0 plus 0. So it's minus that. And then we have 5 to the third over 3, which is 125 over 3, plus, this is 25 right here. And 25 is the same as 75 over 3. So we have 125 over 3 plus 75 over 3. Which is 200 over 3. the thing is, here we have 150. It's going to be 150 minus whatever we got doing that. 150 minus this result. It's 150 minus whatever that is. It's 150 minus whatever that is. 150 is the same as 450 over 3. So it's 450 over 3 minus 200 over 3, which is 250 over 3, which means 250 divided by 3, which is $83.33.